Hello everybody, good evening. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. This is the channel for your complete solution of computer science problems, including your semester exam preparation, including your GATE exam preparation, including the placement preparation also, and there are so many other things which we are providing here on this particular channel. So stay tuned on this particular channel always and share this particular channel as much as possible so that maximum number of students can get benefit out of this. In this particular lecture, I am going to talk about binary search tree in the tree data structure, and more specifically the insertions, deletions, and the complexity of searching insertion and deletion in the binary search tree. So without any delay, let's start the session. Before I start the session, I will introduce myself for those members who are new here and who don't know about me. My name is Vishvadeep Gothi. I have written the GATE multiple times. 19, 119, 440, 682 are the rank. Masters from IISc Bangalore, another masters from BITS Pilani in data science, a rich experience, and these are the courses which I am dealing with on Unacademy's platform. These credentials are sideway, the main motive because of which I am here in front of you guys is the quality education. My entire team, preparing or giving you a lot of content in terms of quality educations on this particular channel, and that particular team is working a lot of very hard for you guys, for your preparation, for your quality education. So what else you can get from my team? For that, you need to stay connected with us, and another opportunity you are having from us to learn for free, and that is on Unacademy's platform. Download the Unacademy's app or go to the unacademy.com on the web browser and search my name, Vishvadeep. Once you search my name, follow my profile over there, and over there you can go to the section called as special class. What is so special with these special classes section? The specialty of these special class section is these are absolutely free. Only thing you need to do is to unlock these special classes, you need to use a code VDEEP10. This particular code will unlock the special classes for free. Remember, VDEEP10. This particular code, if you will use, you will unlock all the special classes for you, and these special classes, in fact, you can listen in the live mode also. Daily I am coming live at 4 p.m. for the special classes, so you can listen those classes live, and apart from that, whichever the previous classes I have taken, all those you can listen in the recorded mode. If you want all my previously taken special classes in a playlist kind of organization, then you can go to this URL. Over this URL, I have organized all my previously taken special classes in more organized way. If you are waiting for any kind of test series for free, yes, we have a free test series here. In terms of quality education, we are providing free test series also. Enroll for that test series and enjoy that free test series on Unacademy's platform with the really good quality questions. If you guys are serious about your GATE preparation, whether you are a 21 aspirant or GATE 22 aspirant or 23 aspirant, whatever it is, you need to start your preparation, you need to have your preparation, you need to continue your preparation up to the maximum possible level, and that particular level, to achieve that particular level, we help you in that same regards on this platform called as Unacademy Plus. This Unacademy Plus is a platform where you get a closed environment, where you get highly motivated students around you, a well structured, well organized, well punctual syllabus covering option you will be having. And in this particular Unacademy Plus subscription, you will be learning in such a way that you will be able to solve the questions quickly. You will be able to solve the tough questions, complex questions easily. And why it happens? Just because we provide live classes in which you will be asked, or you will be allowed to ask so many doubts, and extra doubt solving sessions will be conducting. We will be giving you so many practice questions. We will be giving you the extra weekly tests for your assessment, so that overall development, overall preparation will be on the perfect track. If you want this particular subscription, Unacademy's Plus subscription, then you use the code VDEEP10 so that you can get 10% minimum discount. Apart from that, you can get my mentorship. Why this mentorship is required? Just because for preparation, definitely you need some kind of mentorship of a person who already this particular gate exam, who has cracked gate exam multiple times. So if you will get my mentorship, definitely it will be helpful for you. Apart from that, I am leading a team. That particular team will help you a lot in terms of your preparation, in terms of your day-to-day activities. So if you want to be connected with my team's effort, then you use this particular code. This particular code will work as a bridge between you and my team. If you want that all the preparation strategy should not be prepared by you, but should be prepared by an expert who works as a personal coach for you, then you should go for Iconic subscription. This Iconic subscription has all the facility of Unacademy plus extra facility of personal coach. The personal coach will give you study planning, so that you will not have to prepare your own plan. You will not have to prepare the strategies. An expert will prepare the strategies for you. Definitely those strategies will work better than your own mind preparation or your own mind's strategies. That person will give you study booster sessions, will give you personalized test analysis, will be given to you some special sets for practice and specialized notes, so that you will have upper hand on the most of the students as an iconic preparation way. So if you want to go for this Iconic subscription, again you have option to get discount if you use the code VDEEP10, and again the same kind of unlock facility is there. If you use this particular code VDEEP10, you will be getting discount, plus you will be getting lots of other benefits, including my mentorship, including my team support, and lot. So use this particular code, get your subscription done as soon as possible, and have your preparation iconic for your iconic रैंक। चलिए तो अब हम शुरू करेंगे लेक्चर, बट बिफोर वी विल स्टार्ट द लेक्चर आई नीड योर एनर्जी just because if you will be excited to learn, definitely the content of learning, the quality of learning should be very high. So I need your excitement, your enthusiasm, so that I can teach you in the most energetic way. पढ़ाने के लिए आपको फील आना जरूरी है, और फील लाने के लिए आपको अंदर से ये कहना जरूरी है कि you want to prepare, you want to learn, you want to understand each and everything. So if you are ready, type down in the comment box you are ready, and we will start the session. Till now we have seen all these things: tree basics, traversals, and based on the traversals, how to draw the tree. Already we have seen in previous lectures, we have seen this recursion on the tree, we have seen full binary tree, complete binary tree, expression tree, and based on that I guess I have gone for k-array tree and all. I have explained you skewed trees also, and I have explained you this binary search tree, its definition, and searching in binary search tree also. Now what we are going to see next is in the binary search tree how we perform insertion. If you don't know or if you don't remember BST's definition, I don't think so ऐसा कुछ होगा, but still for your confirmation let me tell you what is a binary search tree. This is the definition. BST is a tree in which for each and every node, left subtree contains smaller values, right subtree contains greater values. किसी का ऐसा क्वेश्चन आया नहीं. Nobody has asked this particular question, but I want to ask a question from your side to me so that you can understand the concept. Sir, equal key आया तो क्या करेंगे? Do we have a possibility that we can have equal keys, duplicate keys in the binary search tree? Yes, possible. Yes, possible. If we have equal keys, then we should keep duplicate keys in the left side. Ki right side? No, left. No, right. Array, there are two definitions. There are two implementations, two definitions. One implementation says that key, the duplicate keys should be kept in the left subtree. So the definition of BST should be like this: equal and lesser keys in the left subtree, greater keys in the right subtree. Second implementation can be, if we have duplicate keys, then duplicate keys should be kept in right subtree. So the definition should be like this: only lesser keys in the left and greater and equal keys in the right side. Both are correct? Yes, correct. सर अब अगर डुप्लीकेट की आया तो हमको कैसे समझ में आएगा? सर हम तो नादान, हम तो एकदम इनोसेंट, हमको नहीं पता. We are innocent, we don't know where to keep, left side or right side. Don't worry. Arey dhondu beta, just chill. Now what happens in the exam, if you have a BST and if you have such scenario that if equal keys are there, then definitely you will be having equal keys definition given in the question. So you will be having equal key definition given in the question, that equal keys should be kept in the left or right. Okay, chaliye. So now let's talk about insertion in BST. Okay, so let me first take a small tree so that I can explain you insertion. So let's have this particular tree. Is it still buffering? Chaliye. This is the tree. This is the tree. In this particular tree, I want to insert a key. Let's assume insertion of 55. What happens? Now see, the algorithm of insertion is exactly same as the searching. You need to search an empty place for insertion of 55. An empty place for insertion of 55. Okay, so we will go for 50. There is a node? Yes. We will go for tree. Root is there? Yes, there is a root. So from root, 55 should be inserted which side? 55 is greater, we go towards right side. From 60, we get a node? Yes. So from 60, we should insert 55 which side? Left side. Why? Just because 55 is lesser. We go towards left. Is there any node in the left? No. So we will insert in the left 55. Simple. So we are searching for 55. Wherever we get empty place, wahan pe, at their place, at that place, you insert the node. You insert the node. Got it? Chaliye. Next one. Suppose you want to insert the next key, which is 25. Next node inserted 25. Where should I insert 25? You only tell me. आप बताओ 25 कहाँ insert होगा? आप ही बताएं 25 कहाँ insert होगा? First of all 50. 25 is lesser, left side. 25 is greater, right side. 30 say 25 is lesser, in the left of 30 I should insert 25. Good, Shweta. Nice. Amazing. Superb. So I guess you are understanding this point. Let's say I want to insert the key 32. Where should I insert 32? From 50, 32 is lesser, left side. 20, 32 is greater, right side. From 30, 32 is greater, right side. For insertion, we will check always from root which side I can insert the new node, left or right, left, right, left, right. You go till you find empty place and you insert over there. Good, nice, amazing, superb. Now, if suppose you understood the insertion ka method, then can you construct a tree by one insertion? Construction of a BST by one insertion. Suppose if I am saying construct a BST using these keys by insertion of the keys by one. Let's say I'm giving the keys 50, then after that 60, then 55, then 62, then 15, then 20, then 5, then 9, then 2, then 1, then 35. These are the keys. What you need to do? First you insert 50 in the empty BST. So 50 should be inserted at leaf node, at where? Stem, at root. कहां पे? क्या बोलते हैं इसको? Root, at root. Right? 50 should be inserted at root. Very first key which you insert in the BST should become root. Now 60. Just check it out. You have single node BST 50. 60 should be inserted in the right of it. I hope you guys are understanding. Now next. Now you have already a tree of 2 nodes. You need to insert 55 in this. 55 should be in the right of 50 but left of 60. Now next, you already have a tree of 3 nodes. In this you need to insert next key 62 should be inserted here. If you acknowledge, are you understanding or not? मैं थोड़ा जल्दी कर रहा हूं क्या? आर यू गाइज अंडरस्टैंडिंग और नॉट? समझ पा रहे हो या नहीं? जल्दी से कंफर्म कर दो. आर यू गाइज अंडरस्टैंडिंग और नॉट? And then based on that we will go further quickly. So next is what? Suppose this is the tree. Let's make the final tree quickly in the single tree only. Now I will be drawing or I will be inserting all the keys. Next is 15. 50 के left में. Now 20. 50 का left, 15 का right. Then 5. 5 is lesser than this too. 9 less 5 के right में. 2 less और 5 के भी left में. 1 left 1. 35 should be greater 35 should be here. This will be the tree. Clear? अरे क्लियर हुआ कि नहीं हुआ? क्लियर हुआ कि नहीं हुआ? Did you get it or not? Can you please confirm this? Are you understanding or not? Okay, so if you guys are clear, then can you draw the tree for this one? You need to draw the tree. I will draw the tree, and then once you are done and I am done, then you will confirm me that you got the same tree or not. जल्दी से tree बना के बताओ. इसका I will also draw. Root is 18. 5 is lesser, left side. 8 left and right. 19 is greater than 18. 20 greater than 19. 35 greater than 18, 19 and 22. 23 greater but lesser than 35. 9 lesser greater. 11 lesser greater. 16 lesser greater. ओहो एक तरफ ही बढ़े जा रहा है ये तो. 1 less than 18 less than 5. Then 3 less than 18 less than 5 but greater than 1. 25 greater lesser than 35 but greater than 23. 25 will be inserted here. Can you acknowledge if you understood this particular tree construction and you got the same tree or not? जल्दी से एक्नॉलेज करें, जल्दी से एक्नॉलेज करिए. Got it? Okay, चलिए. So if you got this, another example we have. We will have to insert these Sunday to Saturday keys in the BST or we need to construct the BST using this particular keys, and you know the dictionary order. You know the dictionary order, right? That A is smallest, B is next, C is next, and so on. Based on that, can you construct the tree? Let's see. बहुत आसान है. Sunday. First value is Sunday. So Sunday will be on the root. SUN I am writing just because first three character itself can distinguish all the days. Then Monday. M is lesser than S. So Monday should be in the left of Sunday. Then Tuesday. T comes as in the right side just because T is greater than S. Tuesday. Next is Wednesday. W is greater than S, greater than even T also. Wednesday. Here. Then Thursday. TH. T is greater than S. TU is greater than Thursday. Thursday is lesser, so Thursday should come here. THU. Then Friday. F. SU. S say less. M say bhi less. F is lesser. Here. Then Saturday. SAT. SAT is lesser than SU and greater than MO. SAT should come here. That will be the tree. Confirm if you got the same one or not. Confirm if you got the same or not. You got the same? मिला? आंसर आया? चलिए अच्छी बात है. Now let's talk about deletion in BST. So insertion I explained you. One by one insertion की help से we have seen how to construct the BST also I have explained you. Now let's talk about deletion. You don't have to. One thing for sure I can say, you don't have to go into the algorithms of these, that how insertion algorithm should be written or how searching algorithm should be written or something. You don't have to worry about this just because for GATE exam you don't worry about that kind of thing. Yes, but if you are preparing for placement, definitely you will need an algorithm how to write searching algorithm in BST. You need definitely how to write an insertion algorithm in BST or deletion algorithm in BST. But for this one, you don't have to record. Okay, fine. चलिए आगे बात करते हैं deletion in BST. So how we perform deletion in BST? Before we go for deletion in BST, what is given to us? A key value will be given to delete. So for deletion, what is given? Key is given. And first of all, what you need to do is search the key in the tree. So if key is given, we need to search the key in the given tree. Once you search the key and suppose you found the key, after that you need to check out that how many number of children that particular node is having. If suppose you have searched the key, you have successfully searched the key, you have that key in your tree, then you need to find out कि whichever node is containing that key value, जहां पे भी वो value है उसके कितने बच्चे, how many number of children are there of that particular node. So I am now next calculating or next checking number of children of the node. Why this is required? Why this is required? Just because based on how many number of children the node is having, we will be having three different cases. These, the node which we want to delete is having 0 child or 1 child or 2 children. Based on that, we will be having three cases: case 0, case 1, case 2. Case 0 is the node which I want to delete is having 0 child. The case 1 is the node which I want to delete is having 1 child, and case 2 means the node which is having 2 children is case 2. Right? So this is case 0, this is case 1, and this is case 2. Got it? Got it? Understood? Okay, now let's start from case 0 and one by one we will cover all the cases. एक एक करके सारे cases को देखने का. Okay, let me draw a tree for you so that you can understand how the case 0 works. This is the easiest type of deletion. Easiest type of deletion this is. Suppose this is a BST and from here I want to delete a node, suppose 29. We will search first 29, 15, 15 से right में 29, 19 से right में 29. Yes, we found it here. Then we have searched or checked how many children 29 is having? Nothing. If no any child 29 is having, then you can delete it from directly here. After deletion 29, we will be having tree like this. 15, 10, 5, 12, 19, 18, and what should be the right child of 19? If we represent as linked representation of this particular tree, what should be in the right of 19? Previously it was 29. Yes. Now what should be? Now what should be there in this right side of 29? Nothing. Nothing means null. So it's very simple case. It is very simple case. If we need to delete a node which is having no any child, 0 child, then remove it from your BST. Means if 19 is 29's parent and 29 is the right child of 19, 19 के right child में क्या आ जाएगा? Null. Simply delete it. See, basically, theoretically, very easy. Algorithmically थोड़ा सा डिटेल में बता देता हूं. I'll find out 29 is there. Yes, it is not having any child. No, case 0. Yes, in the case 0, what I'll do? I'll check out 29 is the left child of its parent 19 or right child. If it is right child, I will make 19 का right child as null. 29 deleted. If suppose I'll take you an example. I'll take an example. Suppose I want to delete 5. I want to delete 5. What I'll do? I'll remove from 5 from here. इसको remove कर देंगे. इसको remove करेंगे means what? इसको remove करेंगे means what? 15, 19, 18. Remaining tree will be as it is. And look at this. In the left of 10, what will be there? Nothing, null. So what I will do is I will check जो node delete करना है, the node which we want to delete is having how many children? Nothing, 0 child. Then in that particular case, the node to be deleted is which child? Left child of the parent or right child of its parent? If it is right child of its parent, here in the first case, I will make parent 19 का right child is null. If it is the left child of parent in this particular second case, then in that case, I will make left child of the parent as null and then deletion done. समझ गए क्या? समझ गए या नहीं समझे? समझ गए कि नहीं समझे? जल्दी से बता दो ताकि फिर हम आगे बढ़े. आगे बढ़े. चलिए आगे बढ़ते हैं. Case 1. Case 1 means the node to be deleted is having 1 child. Multiple examples I will give you, but before I will give you the example, I will have a really great story for you. Great मतलब इतनी भी great नहीं है कि उससे मूवी बन जाए और मैं करोड़ों कमा लूं, but इतनी है कि जिससे आपको deletion समझ में आ जाएगा. It was very simple. Yes, it is the simplest one. It is the simplest one. Let's talk about the next type of deletion. Suppose in this particular tree, I want to delete a node which is having single child 10. First of all, I will search 10. I'll check out how many children 10 is having. Only 1. Yes. Then in that case, what I will do? देखिए एक simple सा story है. There is a king. That particular king is having only single child. 1 child is there. Okay. Now if that particular king is died, then who will become the king? Who will take the place of the king? The single child. सिंगल चाइल्ड, यस, एग्जैक्टली द सेम काइंड ऑफ थिंग। हाँ, बस इतनी स्टोरी थी, इससे ज्यादा एक्सपेक्ट नहीं करना। हाँ, ये टेक्निकल सेशन है, स्टोरी टेलिंग नहीं है। ओके, सो व्हाट आई वाज डूइंग इज आई वाज saying this, that if you are deleting a node which is having single child, what you will do, in place of 10 you place 5. 5, the single child of 10, 5 will be placed on the place of 10, means in the left of 20 who will come now? 5 will come now. 5 will come now. Now what happens? What happens after the deletion? The tree becomes like this: 20 left में 5, right 30, left का 25 and right 35. I hope you understood this. I hope you understood this. समझ में आया या नहीं आया? समझ में आया कि नहीं आया? नहीं आया तो भी बोलोगे नहीं आया, आया तो भी बोलना तो पड़ेगा कि आया। If you understood, then too you need to acknowledge. If you did not understand, then too you acknowledge. Okay. If you understood, one more time I'm telling you, all of the member here, if you want to learn more content for free in more interactive manner, then you need to join us on Unacademy. It's not only that you will have to join on the Unacademy Plus on the paid platform, you can join us on the free platform also, which is called as special classes. You can learn from my special classes also. Those are absolutely free, and to unlock special classes you need to use a code VDEEP10. You need to use the code VDEEP10 to unlock the free content on Unacademy also. Okay, use this particular code, go for Unacademy's special classes which are free and learn from there. चलिए वापस आते हैं इस पर्टिकुलर पॉइंट पे। ओके, आई विल टेक मोर एग्जांपल्स, डोंट वरी, सिंगल एग्जांपल से हमारा काम नहीं चलता है। फाइन, ओके, लेट्स टेक सच काइंड ऑफ एग्जांपल। अभी राइट साइड में डिलीशन करेंगे। 30 and 25, 21 and 29. This is the tree. Suppose I want to delete a node 30 which is having single child. If I want to delete 30 which is having single child, what I will do? What I will do? क्या करेंगे? क्या करेंगे? क्या करेंगे? बताएं, आप बताओ, आप बताओ, आप बताओ, क्या करेंगे? अरे, what we will do? We will remove 30 from its place. हम डिलीट कर देंगे and its single child 25 should be placed on the place of 30. Means 20's right child should be 25. Okay, fine. So 20, in the left 10, in the left 2, in the right 12 as it is. In the right of 20 we will be having 25. अब एक simple सा question. If the king dies, its single child becomes the king. But अगर उस child के भी children हैं तो क्या उनको मार देंगे? If the child also having children, then should we kill those? No, those will remain as it is in the hierarchy. Yes, so left and right of 25 will be as it is, Nare Baba. 25 children will be as it is, yes, and its entire subtree will be as it is. जितना भी नीचे तक जितने लेवल हैं 20, 50, 30, got it? Got it? So we did not delete any other child of 25. Only one node deleted, 30 removed and then done. Understood how to do this particular case number 1? कैसे ये case number 1 काम किया, ये सबको समझ में आया? आया तो acknowledge कीजिए and let's go for last case, case number 2. This is little bit typical. थोड़ा सा typical है, थोड़ा सा. Okay, now let me take first example. After that I will tell you the methods, and one by one so many examples we will be taking so that you can understand that how this case number 2 is working. Okay, now let's take some example here. When you learn, if you understand, In the physical classes, you smile and I understand as an educator. But there is no any video of you I can see here. So only your comments can explain or express that yes, you are understanding. So keep smiling, make your learning happy, and happily keep learning. That's my motive. So keep messaging so that I can understand you guys are understanding and keeping learning. चलिए अभी in this particular case, suppose I want to delete 10. Now 10 is having two children. What happens in that case? Okay, so let's take that king ka example once again. King ka example once again. That example is, suppose there is a king. Now that king is having two children. Now suppose the king dies. Who will become the king? For that we need to watch a movie called as Bahubali. उसके लिए बाहुबली मूवी पे जाना पड़ेगा. दो किंग हैं या दो चाइल्ड हैं, तो उनमें से कौन किंग बनेगा, उसके लिए बाहुबली मूवी देखनी पड़ेगी. नहीं, ना. We will have some technical solution also for that. We don't have to watch that 3 hours ka movie for that. Okay, now what happens exactly? If you want to delete a particular node which is having two children, then there are two options to delete that node. What those two options are and how the deletion happens, I am writing the statements. I am writing the statements one by one. Okay, चलिए तो क्या है statement? First of all, find in order successor और इन ऑर्डर प्रीडिसेसर. अरे आप टेंशन ना लो, मैं सब बताऊंगा कि ये क्या है. सर ये क्या शब्द लिख दिए, हमको नहीं समझ में आया. What you are writing, sir? I'm not understanding. Okay, don't worry. I haven't explained till now. Once I will explain, then only you will understand. Find in order successor or in order predecessor of the node. Second point, delete this in order successor or that in order predecessor from its place. This will be deletion. This particular deletion will be done using either case 0 or 1. Using either case 0 or 1. जितने भी क्वेश्चन आपके दिमाग में हैं वो सब के सब क्लियर होंगे. यू डोंट वरी कि सर केस 0 या केस 1 ही आएगा और कोई नहीं आ सकता. आई विल प्रूव एवरी सिंगल थिंग इन फ्रंट ऑफ यू इन दिस पर्टिकुलर लेक्चर ओनली. सो फर्स्ट यू अंडरस्टैंड द मेथड. आफ्टर दैट वॉट एवर द डाउट्स यू विल बी हैविंग, I only will ask before even you ask. I know what kind of questions you may have. Every question's answer I will give. Just stick to the solve. Just stick to this particular session. Don't worry. Okay. Chal. Okay. Delete in order successor or predecessor from its place and then position it on the place of on the place of deleted node. Deleted node जो है उसको replace कर दो ये वाली node से. Okay. Now, first of all, what is in order predecessor and what is in order successor? Okay, you tell me what is in order traversal of this particular tree. What is the in order traversal of this particular tree? If I haven't told you this in the previous lectures, in order traversals of a BST is a sorted sequence of the keys in the ascending order. All the keys in sorted order, in ascending order, you will get the what? In order traversal. If you want, you can take the in order traversal anyway. In order traversal of this particular tree will be this. Okay, color change कर लेते हैं, थोड़ा colorful दिखेगा. 5, then 10, then 15, then 20, then 25, then 30, then 35. Suppose I want to delete 10. Suppose if I want to delete 10, what is the in order successor? Successor is after 10, whichever the value comes. After 10, whichever the value comes in order traversal. Whatever the value comes in order traversal. कौन सी value आ रही है in order traversal में? Which value is there in order traversal? In order traversal में after 10, which value is coming? 15. So in order successor of 10 is 15. In order predecessor is just previous value of 10, 5. Simple funda hai. If I will remove 10, sequence should be same to same. I should replace 10 by its nearly equal value. It's nearly equal value. Nearly equal value means either I will replace by 15 or I will replace it by 5, so that binary search tree's definition will still remain same. अगर मैंने 10 को कोई ऐसी वैल्यू से रिप्लेस कर दिया, सपोज मैंने यहां पे 10 की जगह पे लिख दिया होता सपोज ये 25, तो प्रॉब्लम हो जाती ना. BST का डेफिनेशन विल नॉट बी सेटिस्फाइड. लेफ्ट साइड लेसर, राइट साइड ग्रेटर नहीं, वैल्यू विल नॉट बी सेटिस्फाइड. So I'll have to replace this 10 by that value which is around 10, so that my definition of BST will be as it is, preserved. Now what happens in that case? In order predecessor or in order successor I'll have to find out. One by one I will tell you one by one that if we will delete by in order successor, how we will delete, and one by one I'll tell you that if in order predecessor if we are using, then how to delete it. Okay, चलिए तो एक काम करते हैं. पहले using in order successor we will delete. In order successor. Fine. चलिए. In this particular case, I will require your help. Sometimes na I get so bored when I do such kind of things. So when I want something, if I'll be asking in order successor bata do, I will be lazy like a regular engineer. I will be lazy. नहीं, मेरे को नहीं पता करना, तुम बताओ इन ऑर्डर सक्सेसर क्या है, आपकी हेल्प लगेगी. You guys are more intelligent, more energetic and more enthusiastic to learn, so that मजा आएगा. आप लोग और ज्यादा एनर्जी के साथ आंसर देंगे, बहुत मजा आएगा. Okay, let me give you simple example first. $38, $35, $36. So this is the tree we are having, and suppose, okay, let me have a table kind of structure so that we can understand what we are actually doing and when we are doing. Fine. So suppose we want to delete a key which is 10. And we are deleting using in order successor. So what is the in order successor of 10? You only tell me. What is the in order successor? In order successor of 10 is what? What is in order successor of 10? I told you, right? I will need your help. $15. Okay, so if 15 is the in order successor of 10, first of all you delete 15 from its place. 15 को यहां से उड़ा दिया. Now by what case you are deleting 15? You are deleting 15 by the case 0. The deletion of 15 is using case 0. So you have removed 15. Yes. Now what you need to do is you need to replace this 10 by inorder successor 15. तो 15 को यहां पे रख दो. Tree will be like this. 20, it's left 15, it's left 5 and so on. The remaining right subtree of 20 is as it is. I hope समझ में आया आपको. I hope you got it. I hope you understood it. Yes? Okay. Now, if I am saying I want to delete a node 30, what is the in order successor of 30? Sort this particular remaining tree. I already deleted 10. Sort this tree. In the tree, what is the next key after 30 in the sorted sequence? What is the key after 30 in the sorted sequence? And my answer should be 35. 35. Now, if we want to delete 35, by which case? First of all, what is the method? Find the in-order successor. Okay, found 35. Delete 35 from its place. If we delete 35 from its place, then deletion of 35 will be using case number 1 now. Case 1 लगेगा. Case 1, using case 1, delete 35. Delete 35. Case 1, okay, 38 के left में 36. Now you need to replace 30 by 35. So the tree will be like this. 20, left 15, left 5, 20 is right 35, left 25, 35 is left 40, 40 is left 38, 38 is left 36, and 40 is right is 50. Just check out that if the tree is still a BST or not. If the tree is still a BST or not. Check out. Yes, it is still a BST. Right? Now, if you will say, sir, can't we have in order successor? Can't we have in order successor with deletion of in order successor with case 2? No, you will not have. Why? Just because. Look at this. 35 is here. अगर 35 के left में भी एक key आएगा, that will be lesser than 35. Yes, but that should be greater than 30. Why? Just because entire subtree, this entire subtree is in the right of 30. You are already in the right of 30 and left of 35 should have a key between 30 and 35. Suppose you have a key 33. If you have a key 33 here, then 33 will become in order successor, not 35. 33 बनेगा in order successor. 35 नहीं बनेगा. So it's very simple. It's very simple to understand that if you guys are deleting any in order successor, then in order successor in this particular case 2 will always be deleted either case 0 or using case 1, never case 2. केस 2 नहीं आएगा. अगर केस 2 आ रहा है मतलब आपने कहीं गड़बड़ की है, या तो आपने सक्सेसर ठीक से फाइंड नहीं किया या फिर आपका ट्री गलत है. Otherwise you will not have any kind of such kind of case. चलिए सेम चीज अब इन ऑर्डर प्रीडिसेसर से करके देख लेते हैं. Let's see if we will delete the node which is having 2 children using in order successor, what happens? I hope you guys are enjoying the session. इतना तो शाहरुख खान ने ओम शांति ओम में नहीं पूछा होगा कि तुम बोर तो नहीं हो रही पोस्टर से, जितना मैं पूछ लेता हूं कि तुमको समझ में आया कि नहीं आया, बोर तो नहीं हो रहे हो. अरे दैट्स माय ड्यूटी रे बाबा. चलिए आगे बढ़े. Let's see, there is an example for in order predecessor so that you can understand it properly. ओहो 40 कैसे आ सकता है यहाँ पे. 25 and 35. Let me take value 5 here, 2 here, 10 in the left side, 6 in the right side, 12 and 18 and 16, 17 and 15. Fine. Okay, now suppose if we are deleting using Inorder Predecessor, let me have the same kind of table here also so that I can explain you what we guys are doing. Your notes will be prepared in the better organized way. Fine. So first of all, let's see what is the a value which we are deleting. Then we need to find out Inorder Predecessor. And case for deletion of predecessor. चलिए बढ़ते हैं आगे. सबसे पहले देखते हैं एक डिलीशन सिंपल वाला. सपोज यू आर डिलीटिंग अ की 30. If you are deleting a key 30, what should be the key just smaller than 30 in the sorted sequence in this particular tree? 30 से just छोटा की कौन सा है? Before 30, what should be there in the ascending order of the keys? Value in order predecessor. बताओ 25 it should be. If it is 25, then what is the case of deletion of predecessor? Do we have any children of or any child of 25? No, it is case 0. Delete 25 from its place. कर दिया sir. Replace the deleted node by 25. कर दिया sir. चलिए. Fine. Okay, next thing. Suppose we want to delete a node 20. 20 is having how many children? 2. This one and this one. Okay, what is the Inorder predecessor for a 20? 20 से Inorder predecessor क्या है? In the left side. In the left side smaller value में which value is just before 20? 18. 18 is the Inorder predecessor. Got it? चलिए. If 18 is the Inorder predecessor, first of all delete Inorder predecessor. How many children Inorder predecessor is having? Direct तो एक ही child है 18 का. Only single child? Yes. So which case? Case 1. What happens in that case? 18 will be deleted from its place and this particular 12 should have right side 16 and now replace the deleted node by 18. So my tree will become like this. Root is 18, left side 5, left side 2, 5's right is 10, left is 6, 10's right is 12, 12 का right होगा 16, left में 15, right में 17 and 18's right should be 25, 25's right 35. Can you confirm you got this or not? Can you confirm you got this particular point or not? क्या आपको ये इतना समझ में आया कि नहीं आया? Got it? Got it? Now I will give you few small insights. Inside story. Okay? How do you find Inorder successor? What is Inorder successor? Inorder successor means value next in the traversal. Inorder traversal में next value. Inorder traversal में next value means what? Look at this. If suppose I want the Inorder successor of 20. Inorder successor of 20 is 25 means in all the greater values of 20, the smallest value, the value which comes as smallest value in all the greater values. समझा क्या कहा मैंने? सारे के सारे जो ग्रेटर वैल्यूज हैं 20 के, उसमें से सबसे छोटी वैल्यू, राइट? सो हाउ डू आई फाइंड ग्रेटर वैल्यूज ऑफ 20? आई विल गो टुवर्ड्स राइट. Greater values of 20 is in the right. Now among those smallest means from 30 go left, जिसका left child नहीं है. I will go towards left. 25 का left child नहीं है. That is the in order successor of 20. Here also, suppose from 30 I want to go for in order successor. I go towards right side, and from there left, I have reached 35. Its left child is not there. No, then 35 is the in order successor of 30. Look at this. Got it? Then in order predecessor इसका उल्टा. In order predecessor will be just opposite of this. How in order predecessor is? Go towards left side and then right. Like this way. 20 का in order predecessor was what? One left side you go, just because you need to search the smaller key. In the smaller keys, you need to find out the maximum key just before 20. So go towards right, and its right is nothing. So 18 should be the in order predecessor. कुछ बोलोगे? समझ में आया या नहीं आया? कुछ बोल पाओगे या नहीं? जल्दी से बताओ, कुछ समझ में आया या नहीं आया? डिड यू गेट इट और नॉट? चलिए आगे बढ़ते हैं. अगर आपको ये इंसर्शन, डिलीशन और सर्चिंग समझ में आई है, इफ यू गॉट दिस इंसर्शन, डिलीशन एंड सर्चिंग, देन बेस्ड ऑन दैट वी आर गोइंग टू फाइंड आउट द कॉम्प्लेक्सिटीज ऑफ सर्चिंग, इंसर्शन एंड डिलीशन इन द BST, राइट? चलिए, सो BST का सर्चिंग कॉम्प्लेक्सिटी कितना होता है? फाइन. Okay, so for that I would like to have one particular tree. Any kind of BST, suppose you have. Suppose this is a BST. I am not keeping the keys. But maximum how many number of comparisons you can have? You will have a comparison on the root. Then from there either you go towards left or right. Then from there you will go towards either left or right. Then you will go towards either left or right. Then left or right, or either left or right. Means what happens? You guys are going to go till the maximum comparison. एक comparison इस level पे, then one comparison on next level, one comparison on next level, one comparison on next level, one comparison on next level. Maximum how many comparisons you can have? Maximum big O of height comparison you can have. मैक्सिमम हाउ मेनी कंपैरिजंस यू कैन हैव? जितने की लेवल्स हैं, और कितने लेवल हैं? अराउंड हाइट के बराबर. सो इफ द हाइट ऑफ द ट्री इज h, देन मैक्सिमम हाउ मेनी कंपैरिजंस यू कैन हैव इज h नंबर ऑफ कंपैरिजन फॉर सर्चिंग द एलिमेंट. सो आई शुड राइट द कॉम्प्लेक्सिटी ऑफ सर्चिंग एज big O of h. big O of h क्यों लिखा? theta of h क्यों नहीं लिखा? Why big O of h? Just because here also you can get an element. If not, then here also you can get an element. Or if not, then you can get element here also. So you can stop your searching if you get an element. If you don't get, maximum h number of comparison you will be making for height h. Now in the BST, the height can be what? If you have an average or best case, if you have an average or best case, the height of an BST can be log n. Height of BST can be log n means you will be having a tree like this, perfectly balanced, barabar nodes every side, almost barabar nodes in every side. But if you have worst case, then in the worst case the height of a tree can be equal to n. कैसे? अरे एक ट्री ऐसा भी तो हो सकता है. BST, yes, possible. Look at this, 4 nodes are there and height is almost equal to 4. Height is also almost equal to 4, right? So based on this complexity of searching, the average case complexity of searching is equal to log of n base 2. And the worst case complexity of searching is big O of n, just because height can be up to n in the worst case. Now, if you were there since starting along with me in this particular session, I have told you guys that searching ka same algorithm we are going to use in the insertion. Insertion is nothing but searching for empty place, same algorithm as searching, and place the value, place the key on that particular empty place. So insertion will also have same algorithm. Yes, if same algorithm, then complexity same to same ही लगेगा. Big O of h, then big O of log n if the best case or average case, big O of n in terms of worst case. And for deletion also, first of all, what you are doing? First of all, you are searching the element. If you are searching the element, how much complexity it takes? Order of h. After searching the element, you are checking if element is having number of nodes, how many. वो constant time operation है. Right? After checking, you are calling either case 0 or 1 or 2. If suppose you are calling for case 0, then case 0 will be having only constant time operation, updation the parents left and right child. If it is case 1, after searching and getting to having single child, again it's a constant time operation, updating the left or right of that particular parent as the single child. Now if we have 2 children, if we have the node to be deleted and that node is having 2 children, what is the complexity? Suppose I wanted to delete this particular node, 40. First of all, searching up to some middle height. Up to some middle, I am searching the element. So from here to here, this much complexity for searching. After that, its inorder predecessor or successor will be where? इसके नीचे ही मिलेगा. इसके नीचे ही मिलेगा. Under this only you will be having inorder predecessor or successor. Yes, here or this side. So in that case, up to maximum what level you will be going? For searching, you will be going up to half. Then after that, inorder successor or predecessor searching, you will be going remaining half. Total how much tree you will cover? Up to the height of the tree. Up to the height of the tree. If that is the case, then for deletion also I am writing the complexity same big O of h, and remaining exactly average case big O of log n, and for the, so remember, searching, insertion, deletion all are same to same complexity in binary search tree, which is big O of h. Height can be in the average case log n, in the worst case n. चलिए कंफर्म कीजिए if you guys got this particular point or not. आपको इतना समझ में आया कि नहीं आया? चलिए बहुत बढ़िया. ओके, कमेंट आया है कि सर आपके डेटा स्ट्रक्चर के कोर्स से कॉन्फिडेंस आ गया है, कमाल की है आपकी टीचिंग. थैंक यू सो मच डियर अहमद खान. आपका जो कमेंट है या कॉम्प्लीमेंट है, थैंक यू सो मच फॉर दैट पर्टिकुलर कॉम्प्लीमेंट. फॉर ऑल द कोर्सेस वी गाइज आर हैविंग अ टीम ऑफ मेंबर्स, and for DA we are going to present a new teacher who is equally good, and that particular new educator will start taking the classes very soon, very soon. So you will be hearing from us very soon that who will be the next educator and what the subject the new educator is going to take. Okay, चलिए, तो आज का ये सेशन आई गेस इतना ही था. अब नेक्स्ट क्या है? इन द बाइनरी सर्च ट्री आई एम गोइंग टू हैव सम डीपीपी. स्पेसिफिकली इट्स नॉट डीपीपी, आई हैव गिवन इट लाइक दिस वे, concept through questions. So I am going to solve some very unique questions of binary search tree, and then based on that I will explain you that if you will solve that question regularly, you will take 2 minutes, 3 minutes, 4 minutes, and if you will learn my methods, you will solve the same question maybe in just seconds or under 1 minute. So definitely that particular session is gonna be a very important for you, just because BST is having so many questions in the previous year gate, and it is having really high probability to be asked in the next future gate exams also. So don't miss that particular session. Tomorrow we are going to have that particular session, same 7 p.m. If you guys are learning for free, then tomorrow I am going to have a COA PYQ session also at 12 p.m. and that particular session is ऑन माइक्रो प्रोग्रामिंग, एक ऐसा चैप्टर, एक ऐसा टॉपिक जिसके सॉल्यूशंस आपको बहुत रेयरली मिलते हैं. हाउ टू सॉल्व, हाउ टू अंडरस्टैंड द प्रोग्राम्स, माइक्रो प्रोग्राम्स in the COA, and how to solve those questions I am going to explain tomorrow. And then tomorrow I am going to have a very special class which is free. That special class is on, I have taught this data structure. I have taught this data structure on Unacademy Plus, and after the entire syllabus I have taken their mega quiz. Mega quiz means that was a quiz on entire syllabus. So I am going to discuss the question of this mega quiz tomorrow in the Unacademy special free class at 4 p.m. You go to my profile on Unacademy. My name is Vishvadeep. ये नाम सर्च करिए, मेरा प्रोफाइल मिलेगा, एंड यू फॉलो माय प्रोफाइल. इफ यू नीड to unlock the special classes, then use this particular code VDEEP10 to unlock the special class. This will be mega quiz discussion tomorrow at 4 p.m. So all these 3 classes I am going to conduct for you guys for free. Please आप सारे sessions को live attend करिए definitely, and after that you will definitely learn a lot. Okay, there are so many lectures we already having. This is my COA series I am having. That is the full length course of COA, and that is one of the toughest course. So if you have some basic idea of COA already, then you can go for my COA crash course. If you don't have any idea of my COA course, then you should go for full length course. Of course, full length course will take a lot of time to learn, but it is having every single detail. But if you are having a basic idea of COA and some knowledge, then you can go for crash course so that you can quickly finish that particular subject. Then all these educators are the team. That particular team we are having, this particular team is very strong team of the educators. Every educator is having at least 10 years experience, and every educator has cracked any of the competitive exam, maybe GATE, maybe NET, maybe some other PSU exam. So you can rely on this particular team, and this particular team is working a lot for you guys. You need to acknowledge by coming for every session live. Plus you need to like every session. You need to, sessions are done, once the live sessions are done, वापस आए, पहले दूसरे जो भी लेक्चर आपको समझ में आता है, whichever lecture you like, you love, you enjoy, in those lectures you come back after finishing this live streaming and drop your comments, so that we will be getting your feedbacks, so that we can improve, so that we can provide more and more motivated content, more content to you guys. If you want to have the PDF of all these lectures which I have taken, then you can join this Unacademy Gate CS channel on Telegram. You will be getting the content, all the PDF which I am writing right now, annotated PDF on this particular channel. And if you want to be connected with us, these are the Facebook pages to be connected with us. And if you have friends in other fields, other domain, other stream also, you need to recommend our family channel to them. What are the family channels for ECIN electrical? This Creatrix channel, for Unacademy Gate MEPIXC channel for mechanical people, civil people के लिए ये channel है, SSC JE GS Terminal for general study subjects, and your own channel Unacademy Computer Science for CS related solutions. Like every single video which you watch here, either live or offline, share these playlists, share these videos and this particular channel with all of your friends. Subscribe the channel, and of course this घंटी बजा दो, turn the bell icon. This particular bell icon will enable the notification. Thank you so much for providing your valuable time. Another session is going to start at 8:15 p.m. about crash course on TOC. That also you watch, definitely you should, so that you can have a good learning out of it. Happy learning everybody, keep learning, enjoy learning, and thank you so much for joining us live here. We will see you soon. Till then, have a nice remaining